Hello guys, welcome to my channel. In today's video I would like to talk about transformers. Transformers are a very important part of electrical engineering. They are used everywhere from generation, transmission and distribution. Even in low voltage applications like in domestic applications, let's say at home, you'll find a lot of appliances that will have a transformer. But what is a transformer? A transformer is an electrical device that transforms voltage. It can transform it in many ways. You get step-down transformers, meaning the primary voltage will be higher than the secondary voltage, meaning it's taking a voltage from a higher value to a lower value, which is stepping down. You get step-up transformers. They take a lower voltage value, they transform it to a larger value called step-up transformer. But you also get isolation transformers. Isolation transformers have got a 1-to-1 ratio. When you want to separate two electrical circuits, so you're going to have a primary winding and a secondary winding, then the voltage on the primary, let's say it's 500 volts, and the voltage on the secondary is 500 volts, but the two circuits are electrically isolated, hence the name isolation transformer. So it isolates two circuits. All right, now you understand the function of a transformer. Let's just go to the components. You get a primary winding, this side. You get a primary winding and a secondary winding. As you can see on the identification plate, it talks about primary voltage and secondary voltage, primary current and secondary current, and the volt amperage rating. That is the power rating of this transformer. If you notice, the power rating is 800 primary, it's also 800 secondary. That is due to losses. From 862 to 800 is just because of losses. But the point I really want to highlight is that as much as the transformer transforms the voltage, it does not transform the power. You can see the power rating is still 860 this side is 800. So what happens, as the primary voltage is stepped down, the current is going up. You can see the primary current is 1.5 amps, but the secondary current is 7 amps. So it still gives you the same power rating. The only difference in power rating is because of losses. You get losses during the transformation process. So that's why now you're gonna get 862 on the primary, but on the secondary you get 800 volt amps. That's basically the reason that is there. Okay, now we know that the primary winding is 550 and then the secondary winding is 110. Let's turn it like this. So the wires to your primary windings will connect this side, and then the wires to your secondary winding to that side. It's a simple live and neutral connection. So this is going to be neutral, this is going to be live. But this has got an extra feature. These are called tappings. So you can have tappings on your transformer, meaning you can use the neutral and 500, the neutral and the 525, the neutral and the 550. Okay? But on the secondary, you'll notice that there's only two wires. It's a live and a neutral. So this is going to be your secondary winding, this is your primary winding. So the most important components is the winding. So these are the windings. If you can look, let's just put it like this. It's a winding. It's a copper wire that has been wound around. That is why it's called a winding. So the primary winding and the secondary winding, they will look the same. It's just the number of turns or the number of windings that are. Because this is a step-down transformer, the primary windings will be higher. The number of primary windings is higher than the secondary windings. That's what does the transformation. So you get the primary winding and the secondary winding. The third important component is the core. Some transformers will get an air core, meaning there's no core. But most transformers in industry will have a steel core. It's made of laminated plates. These are steel plates. They are laminated and they are also insulated using a vinyl insulation. So this is the core. So the core is like, that's where the magnetic field is going to be transported from the primary to the secondary. Remember, between the primary and the secondary windings of the transformer, there's no direct connection. So the core is what causes it's what causes the transformation. So it is the path, it is the pathway for the current to travel. So what happened? The primary winding is wound on this side. It's wound on this side. And then when I inject voltage or I induce EMF here, that EMF will create a magnetic field. That magnetic field will travel on this iron core. And it's going to circulate like this on this iron core. And then what's going to happen? The secondary winding is going to catch that magnetic field and take it on the other side. So there's no direct continuous connection. If you test between the primary and the secondary winding, there won't be continuity because there's no direct connection. The voltage is induced. You inject a voltage on the primary, it generates a magnetic field around the core, and then the secondary winding gets that voltage through induction. Okay. All right, I think I did mention the most important parts. In the second part of this video, we're going to cover a larger transformer. I just wanted us today to cover the basic components, which is the primary winding, the secondary winding, and the core. The cooling of this transformer during transformation is going to warm up and heat up, but because it's a very small transformer, we just use air. Normally where it is installed, there will be a fan close to it to just keep it cool. But when you get to larger transformers, you use other cooling methods like oil and larger fans and all those kind of things. But for smaller transformers, the natural cooling is just sufficient. Okay, so you'll find a lot of transformers, like I said in the beginning, starting from generation. Most of the time when electricity is generated at a power station, it's going to be generated at a smaller voltage. When I say smaller voltage, say maybe 11,000 kilovolts as an example. And then it's going to be transformed to a higher voltage using this device, transformer, to about 132 kilovolts. In some cases, even as high as 400 kilovolts. And then it gets transmitted to the users. So it is cheaper to transmit voltage at a higher value because when you increase the voltage, you drop the current. And when you drop the current, you can use a smaller cable. So that's why transmission lines will take the voltage. At power station, you're going to step up the voltage to a higher value, transmit it at that higher value. And then when you get to distribution points, meaning now substations, at the substation, you reverse the process. You start stepping down the voltage to lower values so that it is conditioned, or it is ready now to be used by consumers. When I talk about consumers, it's factories, industries, and basic people like commercial users and domestic users. Okay, so that's where you get it at the generation side, transmission side, distribution side. Also on your appliances at home, a simple example is a phone charger. The voltage on the wall is about 230 volts. So, but the cell phone charger will step down that voltage from 230 down to about 5 volts, so that voltage is good enough for your cell phone. So transformers are used mostly on those devices, like for that purpose. You will find them everywhere. Very important electrical machines. And another special things about transformer, they are very efficient. Their efficiencies are usually higher. As it transmits the voltage from primary to secondary, you get very little losses. If you compare with other electrical machines like generators and motors, transformers are usually have the highest efficiencies compared to those. One of the reasons is that they don't have moving parts. There are no bearings there, there are no shafts here, there's no moving parts. It's just a steel plate, windings and windings. Okay, thank you guys for watching. I hope you learned something from this video. In my next video, I'm going to cover a larger transformer that has got more components. Please stay tuned for that video. Don't forget to like and subscribe. Enjoy the rest of your day. Goodbye.